So today we are going to learn how to solve right triangles. We're also going to learn how to use our calculator and repeat the same thing that we did in 5.3 when we used the special right triangles. Now we're just going to put the angle measure into our calculator and then hit the appropriate buttons. So when we solve right triangles, we're going to be using Sohcahtoa. So we're going to be using sine, cosine, and tangent. So the first thing you're going to do is label your triangle. You're going to label the angles with capital letters, and you're going to label the sides with lowercase letters. You're going to put the letter across from the capital letter will be the lowercase letter. I'm going to show you this in the next picture. So what we're going to do is once we're done solving the problem, you should have all three angles and all three sides with numbers. So let's go ahead and take a look at our first example. All of the calculations that we do in this chapter are going to be in degrees. So this is why it's always important to check that your calculator is in degrees. Next chapter, when we go back to our regular WebAssign and our e-textbook, we're going to be doing all the calculation in radians, and then we'll have to switch our calculator. So here's our first example. They've actually provided a picture of a triangle for us. So I'm going to go ahead and label with the lowercase letters. So the lowercase letters are going to be across from the capital letters. So here I'm going to put lowercase a so that it's opposite of angle A. And then I'll put lowercase b across from B, and then lowercase c across from C. What I'm going to do when I am all finished here is I should be able to have found the measure of angle A, which was given to me, and I can fill this in here. So I already know that, 31.67. I'm going to be able to find the measure of angle B, which I'm going to show you how to do. And then the measure of angle C was also given to me. Notice it's got the little box here, so it's 90 degrees. So the first thing I'm going to do is find the measure of angle B. So I'm going to reach back to my geometry skills, and you were taught the triangle Sum Theorem, that the three angles of a triangle add up to be 180. After you learn that triangle Sum Theorem, you also learned some corollaries that told you the two acute angles of the right triangle were complements. So the fastest way to find angle B, because I know that A and B together equal 90 degrees, I'm just going to do 90 minus 3167, and that's going to give me the measure of angle B, and it's going to be 58.33. I'm halfway done. Now I have to find the missing sides. So when I'm done, I should have a measure for for side A, side B, and side C. So far I have A, 35.9 kilometers. To find B and C now, this is where Sohcahtoa comes into play. Now, my advice to you is always resort to your given, because if you've made a mistake calculating a different number and you use that in the problem, if you've made a mistake calculating that first number, then everything else is going to be wrong. So for example, if I were to say, you know what, I don't like 31.67, I want to use the 58.33. But what if you're bad at subtracting and you weren't using a calculator and you thought that 90 minus 31.67 was 56.33? And then you go and use that number to find little b and little c, then everything's wrong. So this is why I highly recommend you go back and use the given. So here's how we're going to do it. We're not going to use the 58.33. We've calculated it because that's part of our answer. But now what I'm going to do is I'm going to, box or highlight my given. So let me go ahead and put side length A over here. So this is my given, side length A and angle A. I'm now going to label my sides as opposite, adjacent, and hypotenuse in relation to the given angle. So I'm going to name them based off of angle A. So angle A, opposite is this side little a, the C is the hypotenuse, and the B is the adjacent. Now what I'm going to do to find B and C, I'm going to figure out which trig ratio uses opposite and adjacent, my given and what I'm trying to find. Which trig ratio uses opposite and adjacent? Kate? Tangent. So what I'm going to do here is the tangent of 31.67 is equal to opposite over adjacent, which is little b. And now it's algebra, because tangent of 31.7 is just the number. So what I'm going to do to solve, when the variable's in the bottom, I'm going to multiply both sides by b to get it out of the bottom. And now I have the tangent of 31.67 times b equals 35.9. Whenever the variable's in the bottom, we're dividing to solve. So I'm going to divide both sides by tangent of 31.67. And that's going to give me my answer for little b. And I'm going to round it to the tenths place. So on your calculator, you're going to do 35.9 divided by the tangent of 31.67, and you should be getting approximately 58.195 rounded to the tenths place, 58.2 kilometers. Now I need to find the hypotenuse. So now let me go back and take a peek at my triangle. Again, I'm using my given. So what I boxed in red. So in red, I had the opposite and the angle boxed. So now I need to find hypotenuse. So hypotenuse and opposite, which one am I going to use now? So, right, we're going to use sine. Sine of 31.67 is equal to opposite, 35.9, over hypotenuse. And now I'm going to multiply both sides by c to get this out of the denominator. And now I have sine of 31.67 times c equals 35.9. And now I divide. 35.9 divided by sine of 31.67, which gives me approximately 68.377, rounded to the tenths place, 68.4. This is what we did last year in geometry when we learned about Sohcahtoa. We solved right triangles. Yes?
So, to always find, like for example, like to find C or like B, it's always going to be in the bottom, like when you...
No.
No?
And I'm going to show you next, it's going to be in the top.
Oh.
So everything's going to be different, depending on where it's given and what you have.
Oh.
Yes. So it's not necessarily always going to have the variable in the bottom. Yes?
Are we gonna do every, oh, never mind, I see it to the nearest tenth, I thought it was gonna be like, you do it to the nearest 100%.
Okay, now to the tenths place. Everybody good so far? Now, technically what we could have done, if you were confident in your answer that you got for A and B, you could do Pythagorean Theorem to find C. But again, the problem's gonna occur if you've made a mistake when you calculated this B, then your C is going to be wrong as well. So that's why it's always a good idea to resort back to your original given information. So remember, you can check your answers. Remember the three angles, if you go back and add them, need to total or equal 180. And then you could do Pythagorean Theorem to check your sides. Let's go ahead and try the next one. And then the next one, we're going to see that the variable is going to end up in the numerator this time. Again, every problem is going to be different. And it's not always going to be, we're going to use, like for this one, we use tangent and sine. This next one, we're going to use sine and cosine. It all depends on what's given. So again, I'm going to label my picture. Remember, little a is across from the capital A, little b across from the capital B, and little c across from that 90-degree angle. I'm going to label angle B with 47.8. I'm going to label little c, my hypotenuse, with 89.6. Now, again, I'm going to give each one of the sides the names opposite, adjacent, and hypotenuse. And the way that I name them is based off of the given acute angle. So I'm naming them in relation to angle B. So across or opposite to angle B is little b. So this is the opposite side. This is the adjacent side. And I already labeled the hypotenuse. I'm also going to put everything in there. Okay, so now let's find the missing angle first because that's the easiest part. I just take 47.8 and I'm going to subtract it from 90 degrees. So 90 minus 47.8 and I end up with 42.2. So angle A, 42.2, angle B, 47.8, and then angle C is the right angle. Little a, I don't know. Little b, I don't know, but I do know the hypotenuse. So now let's, if it helps you to identify where your given is, my given is here and here. Next thing I want to do is solve for either A or B. Doesn't matter which one you do first. So we could go in ABC order. Let's find A first. So out of the three things that I boxed, what is the trig ratio that uses adjacent and hypotenuse? And that's going to be cosine, adjacent over hypotenuse. So cosine of 47.8 is equal to adjacent over hypotenuse. Notice this time my variable's in the top, and it's easier to solve. This time I just multiply. So I'm just going to multiply both sides by the 89.6, because over here it makes it cancel. So I'm just going to multiply 89.6 times the cosine of 47.8. And this gives me little a is equal to 60.186, rounded to the tenths place, 60.2. Now I'm going to repeat the process for little b. However, this time I'm going to go ahead and, again, this was my given, and here. And now I'm looking for opposite. So which trig ratio uses opposite and hypotenuse? It'll be sine. So I'm going to do the sine of 47.8 equals opposite over hypotenuse. Multiply both sides by 89.6. Cancels it out of the bottom. 89.6 times sine of 47.8 gives me 66.376, rounded to the tenths place, 66.4. And now I have solved the triangle. I found all three angles and all three sides. Try another example. So again, there's no picture here, so let me go ahead and draw a triangle. This time I'm going to put the B up here, the C is the right angle, and then the other acute angle A is down here. Again, the lowercase a will be across from angle A, lowercase b across from angle B, and then the hypotenuse will be across from angle C, the 90 degrees. I'm going to go ahead and label my picture, 61 degrees, 39.2. And now I'm going to go ahead and find my first, I'm going to find angle B first, because all I need to do is 90 minus 61, leaving me 29 degrees for angle B. So I now have angle A was given to me 61. Angle B I just found by subtracting 61 from 90, and angle C was also given. It's the 90 degree angle. Now I'm going to go about finding the missing sides. So I'm going to go ahead, and I always try to use my given information. So I'm going to be using the 61 degree angle here, angle A, and I'm also going to be using side length B, which is 39.2. So in relation to angle A, little a is opposite, the C is the hypotenuse, and little b is adjacent. So now to find the missing sides, I need to figure out which trig ratio is going to be using opposite and adjacent. And I know that opposite over adjacent is tangent. So I'm going to go ahead and do tangent of 61 is equal to opposite over adjacent. My opposite side is A. My adjacent side is 39.2. I now need to solve for A. So this one's a little bit easier. I just multiply both sides by 39.2. That will get this out of the denominator. My variable is now isolated, and 39.2 times tangent of 61 gives me A is equal to 70.79 centimeters. Next, I need to find C. So C is over here, it's the hypotenuse. Again, I'm going to resort back to my given, which is side B and angle A. So I need to figure out which trig function is going to use hypotenuse and adjacent, and that's going to be cosine. So I'm going to do cosine of 61 is equal to adjacent over hypotenuse. I need to get the variable out of the denominator, so I'm going to multiply both sides by C. So now I have cosine of 61 times C is equal to 39.2. I'm now going to divide both sides by cosine 61. And C is equal to 80.9. And again, these are centimeters. So now I've found all three angles and all three sides. So I have little c here, little a, and little b was given to me. Let's try one more. Again, I'm going to draw myself a triangle, give myself a visual. So again, let me label the angles with capital letters, the sides with lowercase. My C is the 90 degree angle. Angle B is 46 degrees. Little c, this time they're giving me the hypotenuse. So again, easiest thing to find is the other acute angle. It's a complement, so I'm just going to subtract it from 90. 90 minus 46 is 44. So the measure of angle A is 44 degrees. I now have all three angles. So now I need to work on finding the missing sides. Again, I'm going to use my given. So I'm going to be using the 46 and the 29.7. I'm going to label my sides based off the given. So based off the 46 degree angle, this little b over here is opposite, C is hypotenuse, and little a is adjacent. So now I'm going to go ahead and figure out which trig ratio is going to be using adjacent and hypotenuse. And that's cosine. So I'm going to do cosine of 46 degrees is equal to adjacent over hypotenuse. I'm going to multiply both sides by 29.7. And now little a is equal to 29.7 times the cosine of 46, which gives me 20.6 meters. Now I need to find little b. So little b is opposite. And again, I'm going to use my hypotenuse. So the trig function that uses opposite and hypotenuse is sine. So I'm going to do the sine of 46 is equal to opposite over hypotenuse. I'm going to multiply both sides by 29.7. That will cancel that. And now I'll multiply both of those. And b is equal to 21.4. I've now found all three sides and all three angles. So the 90-degree angle for C, the given angle for B, and then the calculated angle for A of 44 degrees. All right, the next two examples are a little different. This time I'm not given an acute angle measure, I'm giving two side lengths. So let me go ahead and again draw my triangle. I'll put B here, C here, and A here. Notice they told us that C is the right angle. So I'm going to put little a over here, little b, little c. Little a is 958, little b 489. Now this one I'm going to solve a little differently. I'm going to first use the Pythagorean Theorem to find the length of my hypotenuse. So I'm going to be using a squared plus b squared equals c squared. I'm going to plug in 958 for A, 489 for B, and I don't know c squared. I'm going to square the 958, 917764, plus 489 squared, 239121. I'm going to add them, and then I'm going to square root it, leaving me c equals to 1075.6 is equal to c. Now, when I go to find missing angle measures, this is where I'm going to use inverse. So I'm going to go ahead and again resort to my given. My given was little a and little b. So in order to find angle A, I'm going to go ahead and label little a and little b with the appropriate names. Little a is opposite to angle A, and little b is adjacent to angle A. So the function that uses opposite and adjacent is tangent, but when you're looking for a missing angle, we use the inverse. So I'm setting this up of tan of A is equal to opposite over adjacent. So my opposite is 958 and my adjacent is 489. So in order to find an angle measure, the way that we're going to put it into our calculator is we're going to do tan -1. Most calculators, you're either going to hit the second key or the shift key, and then I'm either going to enter this as a fraction or do 958 divided by 489. Hit enter, and this is going to round to the nearest degree, 63 degrees. Now, if you're confident in this answer, to find angle B, what we could actually just do is subtract it from 90, and we would get 27. Now what we need to do, just to confirm it, let's do another trig function. Let's go back to our picture, and now let's label the sides based off of angle B. So now little b now is the opposite to angle B, and little a over here is now adjacent. Again, same side, so again I'm going to do tangent. So tangent of B is now, I would flip it, 489, 958. So on my calculator, do the shift key so it opens up tan to the -1, and then either divide 489 by 958, hit enter, and you're going to find that angle B is equal to 27 degrees. Same answer I got when I subtracted. So my calculations for angle A were correct. I've now found all three angles and all three sides, because remember the other angle was the right angle, so angle C is 90. Let's try one more when we're given two sides. Again, add in your capital letters. Little b, little a, little c. Little a is 26.5. Little c is 39.7. First thing I'm going to do is Pythagorean Theorem to find little b. So I'm going to do 26.5 squared plus b squared equals 39.7 squared. 702.25 plus b squared equals 1,576. Move the 702. Subtract 873.84, square root little b rounded to the tenths place is 29.6 centimeters. I've now found all three sides. Now I have to work on the angles. So again, I'm going to use my given, which was A and C. In relation to angle A, this is opposite, this is hypotenuse. So the trig function that uses opposite and hypotenuse is going to be sine. So I'm going to do sine -1 opposite over hypotenuse. And this is for angle A. So angle A is approximately equal to the nearest degree, 42 degrees. Again, if you're confident, subtract it. And angle B is 48. But let's just go ahead and relabel the sides based off of angle B. So based off of angle B, this is now not the opposite anymore. It's adjacent, but hypotenuse is still the hypotenuse. So the trig function that uses adjacent and the hypotenuse is cosine. So I'm going to be doing cosine -1 adjacent over hypotenuse. I'm going to hit enter, and angle B is rounded to 48 degrees. Again, angle C is the right angle. So we have the three angles. And then I had the two given sides. And then the side I calculated. This slide is strictly calculator. Again, there are not buttons that have secant, cosecant, or cotangent on them. So this is where we're going to use our reciprocal identities. And you need to memorize that the reciprocal of secant is cosine. So to figure out what secant of 31.67 degrees is, you're going to do 1 divided by the cosine of 31.67 and rounded to 3 decimal places, the answer is 1.175. Over here, I need to turn these degrees, minutes, and seconds into a decimal degree. Remember, when you convert that, you're going to divide the minutes by 60 and the seconds by 3,600. It turns into this decimal degree. Again, it's the reciprocal of sine. So I'm going to do 1 divided by the sine of 131.757, giving me a final answer of 1.341. Cotangent, its reciprocal is tangent. So again, it's 1 over tangent of 81.8. Once we hit enter, the answer is 0.144. So if you're given sine or tangent and asked to find the value, there are buttons with these functions on them. So all you do is touch the sine button, key in the angle, close the parentheses, hit enter, and there's your answer. Same thing here for the tangent. You'll enter it as a negative angle and get your answer. Okay, so for here, now we're trying to find theta. We did this already in 5.3, but we did it with the special right triangles. Here it's a little bit easier because we're just using our calculator, but our calculator only knows how to find one of the angles. We have to find the other quadrant where it's located and do the math for it. So when we did the homework for 5.3 or learned the lesson for 5.3, remember the quadrants were set up like this. For quadrant 1, this is where the reference angle was located. So remember, if it was a 30-degree angle, this was 30. And then in quadrant 2, we took 180 and we subtracted the reference angle. So 180 minus 30 was 150. And then in quadrant 3, we took the 180 and we added the reference angle and we got 210. And then here, quadrant 4, we did 360 minus the reference angle, and that would have been 330. This was when the reference angle was 30. Now what's going to happen is we're going to get a reference angle from our calculator, and then what we'll have to do is determine which quadrant we need by using our all students take calculus, and then we'll do the either 180 minus, 180 plus, or 360 minus. So let's go ahead and see what to do with an actual problem. So let's look at the first example. It wants me to do sine, and we want to find what angle measures would give us this answer. So what we're going to do here, when we're always looking for an angle measure, that's when we're going to do the second key. So we're going to be keying in sine, -1, and then we're going to put in this decimal. We're going to hit enter, and this is going to give us 42.420 rounded to 3 decimal places. This is the reference angle. So this is the angle measure that sits in quadrant 1. Remember, the angles in quadrant 1 go from 0 to 89, or 1 to 89. Now I need to figure out also where sine, see how this is a positive answer? So this is where my all students take calculus comes in. I need to figure out which quadrant sine is positive. I know it's positive here and here. So to find the other angle measure, I just take this 42.420 and subtract it from 180. And my other angle, or the other answer to this, is going to be 137.58. So the two angle measures that will give us this answer are 42.420 and 37.58. Okay, let's try the next one. We're first going to figure out what the reference angle is by doing tan -1 1.45. The reference angle is 55.408. Going to do my little all students take calculus. I need to figure out where tangent is positive. It's positive here and here. Remember the answer we just got here is for the quadrant 1. It's our reference angle. And to find the angle measure in quadrant 3, we take 180 and we add that reference angle. And then this gives me 235.408. So the two angle measures that will produce 1.45 when I do tangent are these two angles. Cotangent, remember there's no button that says COT on it, so this is where we got to do the 1 divided by. So I'm going to do tangent -1, and then in the parentheses we do 1 divided by 1.27893. When I do this, I get 38.022. I'm now going to add in my all students take calculus. The 38.022 is here. I know tangent is positive here and here, or cotangent. Remember, all 6 are positive in the first one, and then here, this is tangent and cotangent. So now, to find quadrant 3, I take 180 and I add the 38.022, giving me 218.022. So the two answers, or the two angle measures that will give me 1.27893 are those two that I circled. Now, I want to add one example here to show you what to do when it's negative. So let's say instead, let's do a different problem. Let's do the cosine of theta is equal to -0.375. Now, whenever the answer is negative, I'm still going to use that negative answer. I'm looking for which quadrant cosine is negative, and I know it's negative here and here. Everybody with me on that? So watch what happens when I do cosine -1 and I put in -0.375. Tell me what you get. Error. You're doing cosine -1? Shouldn't be an error. It should be 112.
0.02?
Yes. 0.024. Now, where is the reference angle normally located? What quadrant? Normally it's in quadrant 1, right? Where is 112 located?
Which problem is that?
I'm making it up.
2, right?
Correct. Now, the problem with keying in a negative number does not give me the reference angle. This is going to be the answer for quadrant 2. It's 112.024. But how can I get the angle for quadrant 3? I don't know the reference angle to add to 180. So here's how you get the correct reference angle. If this number is negative, key it into this as positive, and then it's going to give you the reference angle, which for this problem is going to be 67.976. So that's the angle in quadrant 1. Notice I don't need that for my answer because cosine's positive there. But I needed it in order to get quadrant 3 because I have to add that number to 180. So the two answers here are 247.976 and the 112.024. You know, technically I could have found the reference angle by doing 180 minus the 112. That would give me the difference, which is the reference angle. But it's a lot easier just to use your calculator and just key in the number as positive. So just be careful. Always remember that the reference angle is going to be something from quadrant 1. Now, someone asked me, do you have to show work for the homework tonight? I want to see the ratios, like when you're solving the right triangles, I want to see the ratios you're setting up. So I had all that work for those triangles. That's what I want to see. However, for this part of the homework, the beginning part, you don't have to show work because it is calculator.
Can I see the problem that you made up?
The problem I made up is in blue, right here. I said find theta when cosine equals negative 0.375. And my two theta answers are circled in black. The next part was where we did the similar thing to what we did with the reference angles for the 30, 60, 90 and the 45, 45, 90.